All right, welcome to the second edition of the video series on SPSS Assignment 5. We'll be taking a look at the example from the Yaki text on simple regression. So let's just kind of review what this example is about. In Chapter 13, Yaki discusses two measures that are going to be used in this simple regression. One is social support, which is going to serve as the independent variable, or since this is a regression, we can also refer to this variable as the predictor variable. And there's some sort of social support inventory that was used to measure the degree of support that college students received from their peers and others, and the total score on this particular inventory ranges from an 8 to a 40. The criterion variable, or the dependent variable, is well-being, and there's a separate instrument measuring that particular variable, and scores on that instrument range from 10 to 70. The research question that's investigated by this example is, does social support predict psychological well-being in college students? So that fits along with our basic objective for our simple regression, is that we're trying to figure out if one variable can be used to predict another. Then our null in alternative hypotheses is, in the first case, the null is that the beta weight, or the standardized regression coefficient for social support, is equal to 0. So remember that that variable is related to the slope of that best fit line. So the null hypothesis is that there's really no relationship between the social support and well-being variables, whereas the alternative hypothesis, if we should reject the null, is that there is not that there is a notable slope to that line of best fit when plotting that line against those two variables. So that just kind of takes us to look at the various components to that, and then lastly, let's take a look at how, and remember how we can use the regression equation for prediction. Recall that we have this basic equation for the line of best fit, which is our y hat, which is the predicted score on the criterion variable, is equal to the y-intercept, or in the output from SPSS is going to be called a constant, and then that's added to the slope of the best fit line, or our regression coefficient, and then finally we have the x, which is our value on the independent variable. So next I'm going to switch over to SPSS and take a look at the data set. So here we can see that we have two variables. We have a support variable, which again is our independent variable, and well-being, which is our dependent or criterion variable. Whenever you're doing multiple regression, and one of the first things you want to do is take a look at your data set. So let's take a look at these two variables as a scatter plot. So rather than using Excel to do that, let's model how to do it in SPSS. Remember, that was something we did way back in that first SPSS assignment. So we're going to go to Graphs and then Legacy Dialogues, and then down to the scatter or dot plot. We're going to select Simple Scatter, then Define. Since support is the independent variable, it would make more sense to put that on the x-axis, and then well-being, we'll put that on the y-axis, and we'll then go ahead and click OK. And when we do that, we see that we get our graph. And one of the things that I really didn't go into in detail, and something you might want to pursue, is the fact that you can edit these graphs within SPSS, and you can kind of see that thing popping up there that we need to double click in order to activate this. So if I double click on the graph, you'll see that this new window pops up that allows me to do some changes to the graph itself. So one of the things I could do, for example, is to click on this header here that says well-being along the y-axis, and I can actually change the size of that. So let me say I wanted to make that bigger, as well as the one that says support down at the bottom. I can click at that and make that 16 point font. If I click on the data along the x-axis, I can change that. Let's say I'll change that to 14. One of the things maybe that I don't like about that is I got 0.00, which is a little distracting. So if I right click on one of those and select the properties window, you can see that I have some additional choices. So basically I highlighted these numbers along this axis, and now I'm clicking on number format. Instead of 2 decimal points, 2 decimal places, I'm going to select 0. So you can see that that cleans things up a little bit. If I go over here to this other axis and click on and highlight the numbers on the well-being axis, I can do the same thing, change the number format to 0 and apply that. I'll also want to make that larger, so I think I used 14 for those. So there's that. The other thing that I'm probably going to want to do is that since this graph is related to a line of best fit, I'll want to actually draw the line of best fit within there. So if we look along our options here that are presented at the top, and let me see where I might have that. So I'm just extending this a little bit. You'll see there's a little icon here that says add fit line at total. I'm going to click on that, and when I do that, it opens up this window, but you can see it's also drawn a line in there so that I can see where that best fit line is. Kind of in an annoying way, it's placed this formula or this equation that is of interest to us. So I'm going to make that a little bit bigger so we can just see it here. And we can see this gives us our regression equation that y equals 18.95 plus 1.02 times x. So this tells me that the slope of this line here is 1.02. The place where this actually crosses the y-axis is down here somewhere. So you can see it goes from 10 to 40. I can't really see where 0 is down here, but that crosses at 18.95. I can also see this other piece up here, this linear, r squared linear equals 0.240. I can make that a little bit bigger as well, hopefully. And so now you can see that a little bit better. Once I have sort of made all the changes that I want to make to the graph, if I close this editing window, you'll see that now within your output you actually have that chart. There's a lot of other things you can do. I'm not going to go into all the details of that, but if you want to go in there and play with it, you can change the color of the background, you can change the size of the graph, you can change what the data points look like. There's a lot of things you can do to clean that up and make it look nicer, including adding titles and other things. The other thing about this is that if you have a graph like this and you go up to edit, you can copy special like we have done before, and you can actually copy it as an image. So if you do that and then you select just some sort of Word document or someplace where you want to paste that, you can go ahead and paste that in place, and so that graph that we just edited here, now it would actually be pasted right into like your treatise or your proposal or whatever you wanted to use that for. So that's a feature that's you can use. Personally, I use Excel because I feel like I have a little better understanding and control over that, but nonetheless that shows you what that looks like. Your data as well, one of the other things that you might be interested in looking at is this assumption of normality. So we could go in and again from the first lesson on SPSS, one of the things we did was to create a histogram, and so I want to create a histogram on the variable support, and I want to display the normal curve, and click OK, and we can see here's what the histogram looks like for support, and it sort of fits. There's this kind of wonky stuff up here that doesn't really fit that, but it looks fairly close to it. I could also go back and do the same thing for the other variable, well-being. So if I get rid of support and send well-being over there, click OK. This one looks like it fits even less well, and so to go back to one other thing that we've done in here, you can go to Analyze and Descriptive Statistics and select Explore, and in this case you can take and you can put both of the variables in there, and then one of the options that you can, one of the plots that you can select is the histogram, and select normality plots with tests. click continue, click OK. It gives you a whole bunch of output, but one of the things that you're interested in is this, the test of normality. Remember, we had the Kolmogorov-Smirnov test and the Shapiro-Wilk test. By both of these, you can see that support has a level of significance as greater than 0.05. So that tells us that we should not reject the null hypothesis that the data are normally distributed. We might have more of a problem with well-being. That one's pretty close at 0.49 for the Kolmogorov-Smirnov. However, it's a lot smaller here. So there's a little bit of question about whether well-being is actually normally distributed. So that's something you want to talk about in your discussion, to say that there might have been some problems with normality, so you might have some bias in your results. But anyway, that sort of explains what's going on with that. So next, what I want to do is to actually run the analysis. And so let me go back to our data window. If I can find that here, there it is. And so now I'm just going to walk through the analysis that Yaki did in the text. So I want to select Analyze, and then Regression and Linear Regression. And within the dialog for linear regression, the dependent variable, recall, is well-being, or the criterion variable, and support is going to be my independent variable, so I'll put that over there. And then the next step then would be to select the statistics, and so I want to see some of these statistics displayed. I want to make sure estimates is checked and model fit, as well as descriptives, which will give me the means and standard deviations for my two variables. And I'm going to select continue, and then I'll go ahead and click on OK, and it will give me my output. So let's take a look at that very briefly to see what the output is telling us. Under descriptive statistics, I can see what the mean for support and well-being is. Remember, we talked about the fact that there was some sort of instrument that they used to look at that, as well as I had the standard deviation. I can also see that there were 25 participants in the study for which we had data on both of these instruments. We can also see the correlation between these two. You can see between well-being and support, there's a correlation of 0.490, so that's a pretty high level of correlation between the two. So we could expect that there's probably some significant relationship between well-being and support. If we were just running a correlation, Pearson correlation, this is the place where we would stop. The next table shows us the variables entered. With simple regression, we're only entering one variable into the equation. We got one predictor here, support. When you're running multiple regression, though, you may, one of the strategies is to add some variables and then see how well the model fits, and then maybe add some additional variables to see what sort of change in the fit of the model you might have. So that's one strategy that's available in multiple regression, really not appropriate here. The model summary tells us some important information, the R and the R squared. You're going to want to report this as part of your write-up of the analysis in APA format, because R squared is your effect size. This tells you the percentage of the variance in social support that explains variance in the dependent variable, which in this case is our well-being variable. Okay, so this tells us that 24% of the variance in well-being is predicted by variance in support. Then the ANOVA table tells us, really, is this 2.40, is that significant? Do we have a significant relationship between the two? Does social support actually predict well-being? And here you can see this is significant because P is equal to 0.013.